The first example we're going to take a look at is this one here. So a toy rocket is launched and follows a flight path that's modeled by the equation y is equal to negative 0.03x squared plus 1.2x, where x is the time in air and y is our height of our rocket. Now you'll notice here that we have a couple things already given to us. We know what x and y are, and I'm just going to make a little text box here where I'm going to put all my answers just to save my notes here. So things that we already know that x is time in air, and it didn't give it here, but that's in seconds. And we know that y is equal to the height of rocket. And again, if units were given, that'd be very nice. Here they're not. We're going to say it's in meters. And so there we go. This is going to just let us know kind of what our, I'm going to put it into a different color here so we can see what our notes are. So x is the time in air, which we're going to call seconds, even though it wasn't given to us like that. And then y is going to be the height of the rocket. Again, we're going to call it meters, even though it wasn't given. I'm going to put those in. I need to probably tweak my notes a little bit before we get that there. All right, now the first thing we need to do is we need to graph this out. And when we do that, let's just kind of look at a little bit of what we might see. And so I'm going to draw a line here. Imagine if we shot off a rocket, it's going to go up and then come back down. Now, if this is time, over time, this rocket's going to go up like this, and then it's going to come back down with time, and it's going to follow a parabolic shape, something like that. Okay, I'm just going to quickly change this color just so that it's a little bit easier to see maybe. Let's do orange. There we go. It's still different than the notes. So here we go. We've got our arch. So it's going to go up over time. Then at some point it's going to peak, and then it's going to go down. Now this here, we know that it's going to start here and it's going to end there. Okay, that's where it's going to start and that's where it's going to end. And so what we have is we have to be aware that the domain and range is only going to be for this portion. The rocket's not going to go into the ground. It's not starting in the ground. So that's going to be our domain and range. Now let's graph this out here. I'm going to pull up Desmos. There we go. Too many tabs going on there. Okay, I'm going to pull up Desmos here, and I'm going to type in this question. So we have y is equal to negative 0.03 x squared plus 1.2x. All right, and let's zoom out so we can see it here. Okay, here is the y-intercept, or sorry, x-intercepts, y-intercepts, and there's my vertex. Okay, if I'm going to type vertexes here at 12, and so we know that x equals 20 is going to be our, that's going to be, oh, there we go. That's going to be our y-axis. So I'm going to put that in right away, and so it's on there. Well, if I were drawing it out, I would also make sure to label that. Okay, domain of this is going to be from this point to this point. That's all. Okay, that's the only place that it's going to go. It's going to go from the when it's shot off, okay, to where it ends. Okay, it's shot off here, it ends here. So when we put that in here, domain, okay, is from the lowest value of x, which is 0. Okay, so sorry, center equal to x, which is less than or equal to our biggest value, which was 40. So domain is from 0, not O. Okay. Get that in wrong. There we go. 0 to 40. And because it's from the smallest value of x to the biggest value of x, our range is, again, the smallest value of y is on the bottom. And if we pull that up there, we have 0, and then it goes up to a max of 12. So it's going to be from 0 to 12. So our range is from 0 less than or equal to y, which is less than or equal to 12. That's our range. It goes up from 0 to 12. Okay, that's our domain and range. This was A. And I'm just going to move that over a little bit so it's, there we go. Okay, so that's A, figuring out domain and range. The other ones, so the other questions here, we're going to have to look at other ones. I'm going to have that in part 2 of this video as it's getting a little bit long already.